The Florida Historical Society presents Florida Frontiers is made possible in part by the Jessie Ball DuPont Fund and by
Florida's Space Coast Office of Tourism, representing destinations from Titusville to Cocoa Beach to Melbourne Beach. The Space Coast has a diverse 72 miles of beach, including surf towns and sea turtle nests. We have inspiring attractions, including the Kennedy Space Center, Brevard Museum of History and Natural Science, and the Merritt Island National Wildlife Refuge. More information is available at www.visitspacecoast.com.
And by the Department of State Division of Cultural Affairs, the Florida Council of Arts and Culture, and the state of Florida. For thousands of years, people living in Florida have used canoes for travel, hunting, and fishing. Some of these ancient vessels have been preserved in anaerobic environments, allowing modern archaeologists to study them. Welcome to Florida Frontiers, presented by the Florida Historical Society. I'm Brooke Markel. Hundreds of canoes have been discovered in Florida, some created as long as 7,000 years ago. Advancements in science and technology are allowing us to learn more about these canoes and about our history.
The canoes are just one example of many different opportunities that archaeology has to better understand the past and how people would have experienced life hundreds or thousands of years ago. And so what we're trying to do with the canoes and with all of the other artifacts that we work with is to add a depth of understanding to our shared human experience. What it would have been like to move through these same waterways that we see now 1,000 years ago, 5,000 years ago, what previous humans would have experienced, how they would have interacted with the world around them. And so the canoe is a really important piece in that puzzle, and so this is why we've spent so much time and energy trying to understand and preserve this very important piece of cultural heritage.
The ability to make and use canoes says a lot about how people got around in the world, the speed with which they could move, how far they could go, the kind of resources they had access to. So this tells us that this maritime tradition, this way of life of taking advantage of rivers and canoes for traversing bodies of water, this has a really great antiquity in the Southeast. At least 7,000 years ago, people were building these canoes of a very similar design as they were 500 years ago. So this is a really ancient tradition. This coastal way of life is a really kind of essential part of the coastal lifeway.
What I think is exciting is this kind of opportunity where we have these different types of researchers coming together, because it's those multiple lines of evidence, you know, from the dating, the dendrochronology, and the 3D imaging. And if we're all kind of looking at things and maybe coming to the same, you know, areas that make sense, I think it's much more powerful if we have those multiple lines of indication. And what's interesting with the 3D is that it allows us to kind of forensically look at, well, okay, is that possible? What would that look like? So I think it's a nice foundation to kind of build upon, a platform to build upon all of these other scientific endeavors.
When we get a call about a dugout canoe, the first thing we do is we ask some questions. We want to know where it was found. We want to know how somebody found it, what the condition is currently, and we always tell people to leave it in place. The canoe has been safe there for hundreds, if not thousands of years. It's been preserved in an anaerobic context, and the safest place for it to be is right where it is. Only if it's threatened, and only if there's very good reason and steps put in place to conserve it, care for it, and then ultimately display it, do we remove it from that original context.
Usually it's a member of the public who calls us to let us know about the discovery of a canoe, and what we always stress is to leave it in place. We want to keep it there to safeguard it. It's been there for hundreds, if not thousands of years, and it's usually the best place for it. When we investigate it, we'll get measurements from it and note its typology, and if we feel like it is needed to be moved for conservation purposes, we'll bring it to the conservation lab here in Tallahassee.
The first thing that's really changed in canoe research and canoe conservation and preservation is awareness. And in the 1980s, the University of Florida did a large project to try to gather information about dugout canoes. And through putting ads in newspapers and contacting people and getting information, they really put the word out there that if you find a canoe, the best thing to do is report it. So that's the number one thing that's changed. And in terms of preservation, some techniques have come about that now are doing a much better job of preserving canoes than, say, some of the early techniques like soaking in sugar water. We're not really doing that anymore, but people made do with the best they had at the time. And that at the time, perhaps turpentine and linseed oil were the methods of the day, and now we would rather treat it in a lab under conditions that can, one, be reversed, and two, are going to be more stable over time.
Well, there are a few different things that are done, but the one that I'm most familiar with is polyethylene glycol used as a consolidant, because over time often the cellulose structure of a canoe has been degraded, especially if it's been wet, and polyethylene glycol acts as a wax that fortifies the internal structure.
Unfortunately, we did lose some data due to methods that weren't ideal in the early days. An example of that is a canoe that's now fragmented into a lot of pieces. It was preserved with the sugar method, quote unquote, and it's now a very greasy and probably sweet if you were to taste it. Small fragmented pieces of wood, and that's from one of our oldest canoe sites, De Leon Springs.
The best known site for canoes in Florida is the Noonans Lake site east of Gainesville. There was a period in the early 2000s of really extreme drought, really low water levels in the lake, and people who lived in the area just started finding all these canoes one after another, and they eventually, over the course of several months, excavated something like 100 canoes, and they radiocarbon dated, I think, 55 of those, and those spanned everywhere from 500 years old to 6,000 years old, so it really had the whole spectrum up until historic times nearly.
Honestly, they're all exciting on the scale of all of the dugouts from Florida. So each individual piece of data is important to add to our database, and there's never a time when we say that's not important enough to record. We always record them.
When most people think of canoe archaeology, probably the first thing to come to mind is the thrill of discovery and the subsequent fieldwork. But the reality is that most archaeology is done in laboratories like this Bureau of Archaeological Research Conservation Lab in Tallahassee.
That's right. A lot of the work that we do is done indoors studying the material. So for every 1 day in the field, give or take, we have to spend 5 or 6 times that amount of time working in the lab, in the museum, working in our offices, analyzing the data. And this is particularly important because what we do is essentially a kind of destructive science. You can't re-excavate something that's already been excavated. So as you're taking something out of the ground, you've got to be very careful about how you document the information, and also you have to make sure you make that information available, both in the scientific reports and also out to the public. Because what you're doing when you're excavating is you're removing things from the ground, and that can never be reconstructed again. So this is why we spend so much time outside of the field and in the office preparing reports, trying to put together museum exhibits, all of these things so that once we've excavated our site, we can share it with the world.
In the radiocarbon dating lab, we pretty much get everybody's most precious, most important finds from sites all over the world. So in the field, you see a lot of really cool stuff from one site. But in our lab, we see the most important or most precious things that primary or principal investigator thought was a really crucial piece of evidence for understanding the story of their site. So we get to see all of this come through every day. Every day is different. We always see different things, different really cool things from all over the world. So we kind of look at things more on the molecular level, whereas the field archaeologists are looking at things on the site level. So it's a difference of scale, really.
Radiocarbon dating was developed in 1949 by Willard Libby and quickly became a primary tool for archaeologists to determine the age of objects.
So there's 3 different kinds of carbon that's naturally occurring. C14 is the only one that's radioactive, which means it is made from nitrogen, a reaction between nitrogen and neutrons from the sun, and its destiny is to decay back to nitrogen again. So carbon cycles through the biosphere, through the food web. Once you die, we all die. Eventually, when we die, we stop replenishing that C14 in our bodies, and the C14 continues to decay to nitrogen. So over time, the amount of C14 in your body declines at a rate that's well known and has been well calculated. So if we know how much C14 was in your body when you died, and we can measure how much C14 is in your body after death, we can calculate how long it's been since the organism died.
Since the late 1940s, the methods used for radiocarbon dating have improved.
The biggest change is what actually is being counted. So in the early days of radiocarbon dating, we needed really large samples because we weren't actually counting C14 atoms directly. Instead, we were counting the decay events. We were counting that energy that came off the decay from C14 as it was turning back into N14. So now we're able, through accelerator mass spectrometry, to actually count directly the number of C14 atoms rather than waiting to count those decay events. So instead of using large samples, sometimes up to a kilogram of carbon, we can measure samples as small as 1 milligram of pure carbon. So our precision is better, the sample sizes required are much smaller, and it's actually extended the upper limit of radiocarbon dating a little bit as well.
Radiocarbon dating is used by archaeologists to determine the age of canoes discovered in Florida.
Well, there have been a couple hundred canoes at least that I know of that have been radiocarbon dated in Florida, and wood is a perfect material for radiocarbon dating because it's organic, it has a lot of carbon in it, and we can measure the C14 content of these canoes to get an estimate of how old the wood was, how old is the material that the canoes are made out of. So using radiocarbon dating, we've dated, I think the oldest date that I know of for a canoe in Florida is about 7,000 years old. So this is the first one that's been dated, the oldest one that's been dated. It's possible that there are older canoes that just haven't been discovered yet.
The ancient Greeks observed that rings form inside tree trunks, and in the Renaissance, Leonardo da Vinci noticed that those tree rings form annually. By the early 20th century, dendrochronology evolved as a science.
It evolved with Andrew Ellicott Douglas in the 1920s. It's pretty well known that trees produce annual rings. Trees in temperate environments produce annual rings. But as dendrochronologists, what we're looking at is the variability in ring width. So trees, in their environment, they're sessile, they can't move around. So they're actually kind of integrating into their physical bodies the environmental variability that they're exposed to. So during a drought year, trees in that region will produce a narrow ring. So yeah, that variability in ring width is what allows us to do dendrochronology.
The study of tree rings evolved to help scientists determine more than just the age of wooden objects like canoes.
It started as an archaeological science. So Andrew Ellicott Douglas, his first publication in 1929 in the National Geographic, was about dating the pueblos in the American Southwest. So it really does have its roots in archaeology, so to speak. But it's evolved to encompass all kinds of other fields. So there's dendroclimatology, there's dendroecology. So using that variability in ring width and other aspects of the tree ring itself, we can explore different aspects of the environment.
Along with radiocarbon dating, dendrochronology helps archaeologists determine when Florida's dugout canoes were created. Cross-dating is the first principle of dendrochronology.
There's going to be the pattern of variability in ring widths. So if we have an item, an archaeological piece, say a canoe that is undated, we call that a floating chronology. So we can measure up the rings and we can know that pattern, but we don't know where it is in the context of time. So to help understand that, we use what's called a master chronology. So these have been developed all over the world. There's what's called the International Tree Ring Data Bank, and so that's where you can go as a scientist or just anyone. It's publicly available, and find these master chronologies. So the master chronologies are dated. There's a year associated with each annual ring, a calendar year. So we use statistical methods to line that floating chronology up with the master chronology in that region. And it doesn't happen perfectly every time, but what we're looking for is a match, a statistical match with the master chronology, and that'll actually give us the dates of that floating chronology.
3D imaging is one of the newest technologies to be utilized by archaeologists to study objects like canoes.
Actually, a lot of the types of laser scanning instruments that we're using today in the marketplace actually evolved out of military applications or from the Reagan Star Wars era kind of time frame. And a lot of those have been made in a much more portable fashion and a much more affordable fashion. And so a lot of us are using these kinds of techniques to help us study in different dimensional kind of aspects. And then I'm also doing large-scale kinds of applications where I'm actually looking at landscapes and terrain kind of variables as well.
Archaeologists are using a variety of methods to produce 3D images of artifacts and historic sites.
Basically, you're acquiring information in 3 dimensions about an object, so you can do that through either triangulation kinds of technologies, where you're using a laser scanning instrument, for example, or it could be even at a smaller scale like computed tomography kinds of things like CT imaging or MRI kinds of imaging. Those are all 3D images or can be looked at in 3 dimensions. We're only getting surface values, so we're doing surface data acquisition. And you can also even do that through photogrammetric kinds of tools with same kinds of principles with triangulation and acquiring 3-dimensional information about an object.
3D imaging is making objects like canoes available to researchers anywhere.
Our center at the University of South Florida is actually based out of the library, which is an interesting place to be because we get a lot of cross-disciplinary kind of activities going on. We have a virtual reality studio on campus, and we can actually use a lot of these models in a classroom, in a curriculum, and we can provide them, make them freely available so that people can use them in their own laboratories or classrooms, and much broader, much more collaboration going on through virtual space. The idea of sharing collections, sharing objects is a way to really accelerate learning and information dissemination.
German physicist Wilhelm Röntgen won the Nobel Prize in 1901 for the discovery of X-rays. The use of X-ray machines became common in the mid-20th century. Today, X-ray technology is no longer confined to the laboratory.
Portable X-ray fluorescence, or PXRF, is based on X-ray fluorescence, which has a much longer history. And so X-ray fluorescence can generate geochemical data, and it's based in the laboratory. Oftentimes you have quite big instruments, and they're very expensive. The portable version has been around for maybe 15 or 20 years now. It's becoming more and more widely used in archaeology. So now, really, in the last 5 or 10 years, it's not uncommon to see one of these machines. And there's 2 clear advantages to the portable X-ray fluorescence machine. One, you don't have to prep the samples, so that requires 0 destruction of the samples oftentimes. This contrasts with the XRF machine, or the regular X-ray fluorescence machine, which is in a laboratory, and oftentimes you have to grind up samples, powder them, and turn them into something that can be fed through the machine. But with the mobility of a portable XRF machine, you don't need to do that. And the other, of course, is its portability. So when you're dealing with a large artifact that's not readily transported or something that's particularly fragile, you can bring the machine to the artifact.
The portable X-ray fluorescence machine helps archaeologists conduct a chemical analysis of objects in the field and bring the information back to the laboratory for analysis.
The machine itself is emitting photons, stimulating the sample, and then as the sample is stimulated, it emits photons of its own. And so the machine is counting the photons that it's getting sent back to it. And that information can be used to understand what the element composition is of the sample. And so this particular tool that I use is about the size of a hairdryer, a little bit heavier, and it can go all over the place, and we can collect geochemical data from a wide range of materials. And then when we get back into the office, we can look at the data and try and see patterns or try and understand what the material is made out of. And this informs not only our interpretation of archaeological evidence, but can also inform conservation strategy, how we want to present things to the public, how things can be better preserved and cared for. So there's a wide range of applications for it.
On September 11, 2017, it was discovered that Hurricane Irma had dislodged a canoe and washed it ashore from the Indian River in Cocoa, Florida. The 15-foot, 700-pound canoe captured the public's imagination. The story made the front page of the Wall Street Journal, was published in Smithsonian Magazine, and went viral on social media. The fact that the canoe was challenging for archaeologists to date and analyze just added to the canoe's mystique.
I was lucky enough to get a sample of that canoe, and I was really excited because I grew up in Florida. So to see this was just, I don't know, it was really cool for me to actually get to radiocarbon date it. When we got the results, I knew that it was going to be kind of an interesting thing to explain, because rather than being able to say, oh, this canoe dates to exactly this year AD, we ended up with kind of 3 discrete possible ranges. So it kind of added to the mystery of how old this canoe was, rather than giving a definitive answer.
One of the issues with the Irma canoe is that it's red cedar, which is quite unusual. I guess this is the only canoe in the state of Florida that they've recorded of this species. And there aren't red cedar chronologies in Florida. So that's kind of an issue we've come up against. We're going to try to date it against bald cypress and pine, but because different tree species are they're reacting to the environment a little bit differently than one another, it's a little bit more difficult to do the cross-dating across species.
Testing continues on the Irma canoe, but so far results show that it might have been created in the 1600s, but it could also have been made after 1930. People in modern times have continued to create and use canoes, particularly the Seminole tribe of Florida.
I have a model canoe. I think it's about 3 feet long. It's typical to what we've been making, for at least the last 120 years. We have a raised bow on it, and it's pointed, and it helps us, push through the sawgrass. And I was always told that we borrowed that design from the Spanish ships when they started coming into Florida, and so it's actually adaptation of European boat design. Our older boats were much more flatter. I guess the bow and stern were identical and kind of looked like an upturned duckbill, I guess is the best way to describe the shape of the ends of the older canoes, at least what I've been told through oral history. Because there's unfortunately not really many examples of Seminole canoes before about 1920 or so, or at least even photos of them. There's a few from the 1890s, a few photos, and then before that there's no museum examples or photography of canoes, Seminole canoes before then. So we're not sure exactly how many Seminole tribal groups were using that design, and if that changed at any point, or if we've been using it for hundreds of years.
Prehistoric and historic canoes continue to emerge from the muck and mud around Florida's waterways, catching the attention of both the public and archaeologists.
What we hope to be able to figure out is how these canoes may have been decorated. And this is more than just getting a sense of the aesthetic. We know that, especially in the prehistoric period, that colors and paints were particularly important to people living in Florida and throughout North America. And the idea that someone would spend hundreds of hours producing one of these canoes, and this is what it would take. It's a massive labor investment. We're not just looking at an important means of transportation, but people are spending hundreds of hours making these things. And with that comes a sense of identity, a sense of importance that comes along with the artifact. And so we suspect that they were also embellishing them, decorating them. And these decorations would have been more than just aesthetic. They would have been lending further sense of identity and importance to these artifacts. And so when we step back from just trying to reconstruct what the canoe would have looked like to the larger anthropological questions of what this might have meant to the people using it, then I think we can really start getting at some very interesting questions.
It's exciting when the public gets excited about canoe research, and it's really fun because we don't have to sell it. It's just by nature pretty thrilling to Floridians to learn about something like boats, boat making, and this tradition that goes back thousands of years. We've got the highest concentration of dugout canoes in the world here. We have the highest number of boat registrations in the US. We have the largest number of fishing licenses in the US, and Floridians love their boats. And I think that capturing their imagination and using whatever method it might take to feed that enthusiasm is what archaeologists are trying to do.
Canoes were extremely important to both prehistoric people and early settlers of Florida, allowing for efficient transportation along Florida's waterways. You've been watching Florida Frontiers, presented by the Florida Historical Society. Visit us anytime on the web at myfloridahistory.org. Thanks for joining us. I'm Brooke Markel. The Florida Historical Society presents Florida Frontiers is made possible in part by the Jessie Ball DuPont Fund and by
Florida's Space Coast Office of Tourism, representing destinations from Titusville to Cocoa Beach to Melbourne Beach. The Space Coast has a diverse 72 miles of beach, including surf towns and sea turtle nests. We have inspiring attractions, including the Kennedy Space Center, Brevard Museum of History and Natural Science, and the Merritt Island National Wildlife Refuge. More information is available at www.visitspacecoast.com.
and by the Department of State Division of Cultural Affairs, the Florida Council of Arts and Culture, and the state of Florida.